GCE O Level Mathematics, Lecture 10, Proportion. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. In this lecture, we will learn to understand the ideas of direct proportion and inverse proportion. Determine whether two quantities are in direct proportion or inverse proportion. Solve practical problems on direct proportion and inverse proportion. And lastly, solve joint variation problems. What is proportion? Proportion shows the relationship between two quantities, which means when one quantity changes, how another quantity changes. There are two types of proportion, which are the first type is direct proportion and the second type is inverse proportion. For direct proportion, when one quantity increases, another quantity increases as well. For inverse proportion, when one quantity increases, another quantity decreases. If y is directly proportional to x, then y equals kx, where k is constant. We can plot this equation in a graph and we get a straight line graph with the equation y equals kx. For inverse proportion, if y is inversely proportional to x, then y equals k over x, where k is constant. We can also plot it on a graph. We'll get a parabola or a curved graph with the equation y equals k over x. Now, let's discuss how direct proportion works. As mentioned in the previous slide, when one quantity x increases, another quantity y increases as well, which means that both quantities x and y change at the same rate. If y is directly proportional to x, then y equals kx, where k is constant. Notice that if we rearrange the equation y equals to kx, y over x equals k, which means y over x is a constant. This determines whether the relationship between two quantities x and y is direct proportion or not. Let's look at this table, which gives us an example for x and y. These are the values of x, and these are the values of the y correspond to the value of x. If we want to determine the ratio of y to x or y over x, all of the pairs of the values give us the same constant 2. Hence, the relationship between x and y is directly proportional. Now, if you want to plot these pairs of values on graph paper, this is what we get. We have the x and the y axis, and we label the scale, and then we plot the points one by one. So first point, second point, third point, fourth point, and the last point. Then we join them together. We see that we can get a straight line start crossing the origin 0, 0. Let's look at example 1. The amount of commission earned by a car dealer C is directly proportional to the number of cars and that he sells. If he sells 5 cars, he earns $15,000. What will be the commission that he will earn if he sells 12 cars? Here's a solution. Given that C is directly proportional to N, hence C equals Kn. When N equals 5, C is 15,000. So you substitute this value into the equation, which is 15,000 equals K times 5. So K equals 15,000 over 5, and the constant K value is 3,000. So we can rewrite the equation to be C equals 3000 N. When N is 12, then C equals 3000 times 12, which is 36,000. Hence, the car dealer will earn $36,000 if he sells 12 cars. Now, let's try this example yourself. The power P generated by a machine varies directly to the electric current supply I. If the current supply is 8 amperes, the power generated is 3200 watts. What is the amount of current must be supplied if it is required to generate 4800 watts of power? Alright, here's a solution. Given that P is directly proportional to I, hence P equals Ki. When I equals 8, P equals 3200. Hence, we substitute these values into the equation, which gives us 3200 equals K times 8. Hence, K equals 3200 divided by 8, and the value is 400. So we rewrite the equation, become P equals 400I, when P is 4800. So the equation becomes 4800 equals 400I. I will be 4800 divided by 400, and it is 12 amperes. Hence, a current of 12 amperes must be supplied to the machine if it is required to generate 4800 watts of power. Now, let's look at example 2. The volume of a container V changes directly with the square of its height, h. When its height is 15 centimeters, the volume is 900 centimeters cubed. Calculate its height when the volume is 256 centimeters cubed. Notice that in this example, the quantity V changes directly with the square of its height, h. It is not only h, the height. There is a square here. Hence, the solution will be, given that V is directly proportional to h square, then V equals kh square. When h is 15, V is 900. So we substitute these values into the equation. We get 900 equals k times 15 square. K equals 900 over 15 square. And the k value will be 4. So the equation becomes V equals 4h square. Now, when V equals 256, then 256 equals 4h square. So h square will be 256 over 4, which is 64. H will be square root of 64, and it is 8 centimeters. Therefore, the height of the container is 8 centimeters when the volume is 256 centimeters cubed. Now, you can try this example yourself. The speed v of a moving particle is directly proportional to the square root of its kinetic energy, E. When its kinetic energy is 8,100 joules, the speed is 18 meters squared. Calculate the speed when the kinetic energy is reduced to 2,500 joules. Alright, here's the solution. Given that V is directly proportional to square root of E, hence V equals K square root of E. When E is 8,100, then V will be 18. So we substitute these values into the equation. We get 18 equals K square root of 8,100. So K will be 18 over square root of 8,100, and the value is 0.2. Hence, the equation becomes V equals 0.2 square root of E. When E is 2,500, then V equals 0.2 square root of 2,500, and we get the value is 10. Therefore, the speed of the particle is 10 meters per second when its kinetic energy is reduced to 2,500 joules. Let's look at example 3, which is related to direct proportion involving percentage change. The volume of air in a balloon V is directly proportional to the cube of its radius r. Calculate the percentage of change of the volume when the radius doubles. And here is the solution. Given that V is directly proportional to r cubed, hence V equals kr cubed. Now, in this example, the values are not given to determine the value of k, but we don't have to find the value of k here. Just move on to the information given. When r doubles, r becomes 2r. So we substitute this into the equation, and now the volume is the new value of the volume, which is equals k times bracket 2r cubed. And the new value of volume is 8k r cubed. The percentage change formula is the new value minus the initial value over the initial value times 100%. So for this case, the new value of the V is 8k r cubed and the V initial is kr cubed. So the equation becomes 8k r cubed minus kr cubed over kr cubed times 100%. Then we factorize the kr cubed. It becomes kr cubed times 8 minus 1 over kr cubed times 100%. Then we cancel the kr cubed, which is the value becomes 600%. So the volume of the air in the balloon increases by 700 when its radius doubles. Now you can try this example yourself. The rate of flow of water R from a water tap is directly proportional to the square of the tap diameter D. Calculate the percentage of change of the rate when the tap diameter is half. Alright, here's the solution. Given that R is directly proportional to D square, hence R equals KD square. When D is half, D becomes D over 2. The equation becomes R new equals K times D over 2 square, which is K D square over 4. Now, to find the percentage change, it will be the new value of R minus the initial value of R over initial value of R times 100 square. So R new is KD square over 4. R initial is KD square. So the calculation becomes KD square over 4 minus KD square over KD square times 100%. Then we factorize KD square, which becomes KD square bracket 1 over 4 minus 1 over KD square times 100%. Then we cancel out the KD square, we get negative 75%. Therefore, the rate of flow of water decreases by 75% when the tap diameter is half. Notice that negative value means the flow is decreasing. In the next section, we'll talk about inverse proportion. Inverse proportion means when one quantity x increases, another quantity y decreases. If y is inversely proportional to x, then y equals k times 1 over x, where k is constant. Notice that if we rearrange the equation, we find that x times y equals k, which is a constant. This determines whether the relationship between x and y is inverse proportion or not. Let's look at this table with the x values and the y values correspond to the x. This is an example of inverse proportion where if we multiply the value of x and y together, each pair will give us the same value, which is 12. We can also plot these pairs of values on a graph paper where this is the x-axis and this is the y-axis, and we label the scale x and y. Next, we plot the point one by one. So this is the first point, 1, 12, second point, third point, next point, and continue to the last point. Then we join these points together, we get a parabola or a curved graph with the equation y equals 12 over x. So this is the graph of inverse proportion. We know that inverse proportion means that when one quantity increases, another quantity decreases. But how about this case? Let's look at this table with the x and y values. Notice that when x increases the value, the y decreases the value as well. Can I say that in this case it is inverse proportion? Let's check it out. So what we can do is we can plot it on a graph paper. So this is the x and this is the y axis with the label of the scale. And then this is the first point, second point, third point, and so on. What we get will be a straight line going downwards, and it is a decreasing function. Now, can I say that this is inverse proportion? So what we can do is we can multiply the value of x and y one by one, and we see that the values are not the same. Each pair of x and y will give us different value. So x and y, when multiplied together, they are not a constant. Hence, it is not inverse proportion. Example 4. The time taken, T days, to complete a construction work is inversely proportional to the number of workers W. Given that 12 workers take 21 days to complete a job, find the time taken by 18 workers to complete the same construction work. And here's a solution. Given that T is inversely proportional to W, therefore T equals K times 1 over W. When W equals 12, T equals 21. So we substitute these values into the equation, which is 21 equals K times 1 over 12. K will be 21 times 12, which gives us 252. So we can rewrite the equation, becomes T equals 252 times 1 over W. When W is 18, then T equals 252 times 1 over 18, and the answer is 14. Hence, 18 workers take 14 days to complete the same construction work. Now you can try this example yourself. The pressure of gas P in a balloon varies inversely to the volume of the balloon V under constant temperature. When the volume of the balloon is 100 centimeters cubed, the pressure of gas is 18 kilopascal. What is the volume of the balloon if the pressure of gas is 24 kilopascal? Right? Here's a solution. Given that P is inversely proportional to V, therefore P equals K over V. When V equals 100, P equals 18. So we substitute these values into the equation. We get 18 equals K over 100. So K equals 18 times 100, which is 1800. Therefore, the equation becomes P equals 1800 over V. Now, when P equals 24, then the equation becomes 24 equals 1800 over V. V will be 1800 over 24, which is 75 centimeters cubed. Hence, the volume of the balloon is 75 centimeters cubed when the pressure of gas is 24 kilopascal. Example 5. The force of attraction F between two particles changes inversely with the square of the distance d between the particles, as shown in the diagram. When the force is 25 newtons, the distance is 7 centimeters. Calculate the distance when the force is 140 newtons. So be careful with this question. You have to read it very carefully because the force of attraction F is inversely proportional to square of the distance d, not only the distance, right? Be careful with the word square here. Then here's the solution. Given that f is inversely proportional to d squared, so the equation will be f equals k over d squared. When f is 25 and d is 7, we substitute these values into the equation. We get 25 equals k over 7 squared. So k will be 25 times 7 squared, which is 1225. So we can rewrite the equation, which is f equals 1225 over d squared. So when f is 140, substitute this value into the equation, we get 140 equals 1225 over d squared. So d squared will be 1225 over 140, which is 8.75. D will be square root of 8.75, which is 2.96 centimeters, rounded off to 3 sequence figures. So to answer the question, the distance is 2.96 centimeters when the force is 140 newtons. Now you can try this example yourself. Given that n is inversely proportional to the square root of L, when n is 84, L is 9. A. Find the value of n when L is 49. B. Find the value of L when n is 12. And C. The percentage change in the value of n when L is multiplied by 4. You can pause the video and try to do it yourself. Alright, here's the solution for A. So given that n is inversely proportional to square root of L, so n equals k over square root of L. When n is 84 and L is 9, just substitute these values into the equation. We get 84 equals k over square root of 9. K will be 84 times square root of 9, and the value of k is 252. Now we rewrite the equation, becomes n equals 252 over square root of L. When L is 49, just substitute L equals 49 into the equation. So n will be 252 over square root of 49, and the answer is 36. For B, when n is 12, again just substitute n equals to 12 into the equation. So we have 12 equals 252 over square root of L. So square root of L will be 252 divided by 12, which is 21. L will be 21 square, which is 441. For C, the initial value of n is 252 over square root of L. Now when L is multiplied by 4, L becomes 4L. We can update the equation. The new value of n is 252 over square root of 4L. Simplify, we get 252 over 2 square root of L, or 126 over square root of L. Now, to calculate the percentage change, just apply the formula, the new value of n minus the initial value of n divided by the initial value of n times 100%. The new value of n is 126 over square root of L, minus initial value of n is 252 over square root of L, and over initial value of n, L, which is 252 over square root of L times 100%, factorize 1 over square root of L. Then we cancel it. After that, the calculation is just 126 minus 252 over 252 times 100%, which is negative 50%. So we can say that the value of n decreases by 50% when L is multiplied by 4. Lastly, let's talk about joint variations. Joint variations apply when more than two quantities are considered. Example 6, we'll talk about more on joint variations. 6 workers take 15 hours to make 100 toys. A. How many hours will they take to make 150 toys? 9 more workers join them to make 150 toys. B. How much faster are they compared to only 6 workers making the 150 toys? So this question, the very first thing we need to do is we need to identify the quantities. The first quantity is the number of workers, the second quantity is the number of hours, and the third quantity is the number of toys here. So from here, for A, let X to be the number of hours because this is what we want to find for A, how many hours will they take, right? So then we let X to represent the unknown they want to find. So the next thing we need to do is we can form the ratio, number of workers to number of hours to number of toys. So given 6 workers take 15 hours to make 100 toys. So 6 workers to take X hours and make 150 toys. Notice that the number of workers is the same, which is a constant quantity. Therefore, we can just compare these two quantities, number of hours and number of toys. So we can first identify what type of relationship between number of hours and number of toys. They are direct proportion, as we think that the more toy we need to make, the more hours it will take. So it is direct proportion. Then we can just solve or find the value x using direct proportion, which is 15 to 100 equals x to 150, or 15 over 100 equals x over 150. Then we solve this equation, x equals 15 over 100 times 150, which is 22.5 hours. Next, for B, let y to be the number of hours, as this is the quantity we want to find. The next thing we need to do is we form the ratio of the three quantities here, number of workers to number of hours to number of toys. Now we update the ratio here. So previously we found that 6 workers takes 22.5 hours to make 150 toys. Now the number of workers has increased to 15 because 9 more workers join them. So 9 plus 6, we get 15. So 15 workers take Y hours to make 150 toys. Notice that the number of toys here are the same, which is constant quantity. So we just need to compare these two quantities, and the next thing we need to do is consider what is the relationship between number of workers and number of hours here. So it is inverse proportion because the more workers we have, the less hours we need to take to produce the same number of toys here. So that's why it is inverse proportion. Then we can form the equation using inverse proportion relationship. So 6 times 22.5 equals 15y, right? So notice the difference. Just now, if it is direct proportion, it will be 6 divided by 22.5. If it is inverse proportion, then it becomes multiply, right? So same case for here, 15y. If it is direct proportion, will be 15 over y. This is inverse proportion. So make sure you form this equation correctly. Okay, now once the equation is correct, we can solve for y, which is 6 times 22.5 over 15, and the answer is 9 hours. But we haven't answered the question yet. We need to find the difference. So previously, if you only have 6 workers, you take 22.5 hours. If increased to 15 workers, it only take 9 hours. So the difference will be 22.5 minus 9, which is 13.5 hours faster. Now you can try this similar example yourself. In a university hostel, 300 students consume 20 tons of food in 72 days. How many days can 540 students consume 32 tons of food? You can pause the video and try to answer yourself. Right? Here's the solution. Let x to be the number of days, and then we can form the ratio, the number of students to tons of food to number of days. So these are the three quantities involved in this example. So we had 300 students consume 20 tons of food in 72 days. Next, same number of students, which is 300 to 32 tons of food, can take how many days to consume? So it's X days. Notice that the number of students is the same, so we just need to compare these two quantities, the number of tons of food and the number of days. So these two quantities, the relationship is direct proportion, as the more food we have, the more days we can consume. Then we form the equation 20 to 72 equals 32 to x, or 20 over 72 equals 32 over x. Then we solve this equation. X is 32 times 72 over 20, which is 115.2 days. Next, we let y to be the number of days and update the ratio. So we still have the number of students to the ton of food and the number of days. Update with the new information here. 300 students consume 32 tons of food in 115.2 days. So now the number of students increased to 540. The amount of food the same, 32 tons of food, and how many days? That is y. So the number of tons of food is the same. So we just need to compare number of students and number of days. The relationship between the number of students and number of days is inverse proportion, right? As the more students we have, the less days the food can be consumed. The same amount of food can be consumed. So from here, 300 times 115.2 equals 540y. Make sure you form the equation correctly. So next thing is to solve this equation. Y equals 300 times 115.2 over 540, and the value of y is 64 days. So to answer the question, 540 students can consume 32 tons of food in 64 days. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friends. Until then, see you in the next video. Have a great day ahead.